I'm Rashmi Savera, student teacher. Today we are going to discuss about classification of elements. So let's get into it. First is, what is a classification of elements? The grouping of elements according to their similar characteristics. Substances which are formed by the combination of various elements is called as a classification of elements. So firstly, we live in the world of substances with a great diversity. So the substances are formed by the combination of various elements that are unique in their nature and property. So we are going to see about some of the classification of elements. So the first topic is about the early concepts of elements. The Dobereiner. The Dobereiner, a German scientist, Dobereiner, suggested a method of grouping of elements based on their relative atomic matter, atomic mass, which is arranged in the elements into groups containing 3 elements. So these are called as triads. He showed that when 3 elements in a triad are arranged in the ascending order of their atomic masses. So the atomic masses of middle element is nearly the same as the average of atomic masses of 2 elements. This is called as Dobereiner law of triads. Okay. So the next is Dobereiner's limitations. It is not applicable to elements having a very low and a very high at mass. This is the Dobereiner's triads. The first is the elements has been given. So the first element is lithium, the second is a sodium, and the third one is a potassium, and their atomic weight element are given in the triad list. Okay, and the atomic weight was also given. So the second is a Newland's law of octaves. He is known as John Newland's. He arranged 56 known elements in C order of their atomic masses. He observed that every 8th element had the properties similar to those of the first element, which is known as the first element. Okay, they are similar to their properties. So the limitations are the instances, the elements fitted in the second same slot, that is cobalt and nickel, and which is dissimilar to their properties, and only 56 elements are present, and it has no room in the periodic table. The third one is, this is the new form of the periodic table, that is Mendeleev's periodic table, and it is the modern periodic table also. Elements having a similar properties, and in this periodic table the elements are arranged in the basis of the atomic masses, and it was proposed by the law of periodicity, and it has elements of number 56, and it is the short form of the periodic table. And the features of the modern periodic table are, it has 8 vertical columns, which is also called as groups, and the 7 horizontal rows, which is also called as periods. Group has 2 subgroups, that is A and B. So the elements of similar properties are placed in the same group, that is elements which are present in the 8 vertical columns of the periodic table. And what is the modern periodic table, which depends only on the atomic number, and which is horizontal rows have 7 periods, and which is placed only in the period group. Vertical column has group 18, and it is the extension of the Mendeleev periodic table. The physical and the chemical properties of the elements are the periodic function of their atomic number. So the Mendeleev proposed that the elements of similar properties are repeated in the regular intervals when the elements are arranged in the order of their atomic masses. And this is the modern periodic table of Mendeleev, which has 56 elements in this periodic table, and it has it has eight vertical columns and 7 horizontal rows. Next is about the classification of elements. Electrons in atoms are surrounded by nucleus. Each shell consists of one or more subshells, and they are divided into four blocks. So they are S, P, D and F. So based on the arrangement of subshells, these four are arranged. The first column is about the alkali metals, the second is about the alkali earth metals, and the middle of the D block elements are called as transition elements. And next group 13, group 14, group 15, group 16, next is halogen, and the last column is full of noble gases. First is S block elements. What is S block elements? Which is present in the first 2 rows of the periodic table. Includes group 1, that is alkali metals, include group 2, that is alkaline earth metals, and it is also called as representative elements. Metals combined with oxygen to form oxides are also called as S block elements. Alkaline solutions of these elements can easily dissolve in water. Next is P block elements. P block elements means it has a different type of elements, that is metals, non-metals and metalloids. Metals, non-metals and metalloids. The P block elements from group 13 to 18 in the periodic table include boron, carbon, nitrogen, oxygen and fluorine. Families in addition to noble gases. So this type has different types of elements, that is which I mentioned before is the metals, non-metals and metalloids. So the screen which I place here this is called as the P block elements. Next is D block elements. What is D block elements? Includes a group of 3 to 12 and which is found only in the center of the periodic table. Their properties are intermediate to that S block elements and P block elements, which are also called as a transition elements. And in this, across the group, it increases electronegativity and decreases enthalpy of hydration of carbon and decreasing enthalpy of hydration of cation, and it increase in the electronegativity. So this is called as a D block elements. Next, the last one is F block elements. So F block elements are with elements from lanthanum to lutetium is called lanthanides, and which has 14 elements in the first section. So next is actinium to lawrencium is called as actinides. So that is also included with the 14 elements in the periodic table, and it is also placed in the bottom of the periodic table. It is also called as the inner transition elements. So this is about F block elements. So we saw about four types of blocks. So that is S block, P block, D block and F block. Next is the position of hydrogen and the rare gases. So hydrogen is the lightest, smallest and the first element of the periodic table. So the electronic configuration is 1s1. So it behaves as an alkali metal as well as the halogen elements like helium, neon, argon, krypton, xenon, radon. So these are also called as noble gases, and it is also called as a monoatomic gases, and this element does not react with the other substances also. So these are the position of the hydrogen and the rare gases. Next is, what is a metal, a non-metal and the metalloids? Metals are hard, shiny. From lithium to francium is the metals, and beryllium to radium, which is from the group 3 to 12. It is also called as metals from the periodic table. The non-metals. Next, it does not have the property of what I said in the metals, that is a hard and shiny, and that is also arranged in the P block only. Next, what is metalloids? Which have the property of metals and non-metals, that is hard and shiny, and it does not also have hard and shiny. Next is the metalloids are boron and arsenic. Next to the periodic trends and properties. Elements which repeats after the regular intervals is called as periodicity. So what are this? Atomic radius, ionic radius, ionization energy, electronegativity, and electron affinity. These shows a regular periodicity, that is also called as a periodic properties. So now let's get into it. Periodic trends. The first is the atomic radius. It is the first is atomic radius. It is a distance between the center of the nucleus. In metal, if it is in the metal state, it is also called as a metallic radius. So in non-metallic elements, it is also called as a covalent radius. Okay, so this is the example, which is a hydrogen and a hydrogen. So along the period from left to right, the atomic radius decreases. So along the group from top to bottom, the atomic radius increases. So this is known as atomic radius. Okay, so in this diagram we show the atomic radius of hydrogen atom, which has a ratio of radius of 120 pm. Next is ionic radius. Ionic radius is the distance from the center of the nucleus. So which is a positive charge increases where the size of the cation decreases. The negative charge increases, the size of the anion decreases. Okay, so when the neutral atom loses an electron, it becomes a charged ion, which is called as a cation. When a gain of electron by a neutral atom forms a negative charged ion, it is called as an anion. So as seen in the atomic radius, ionic radius also decreases along the period from left to right and increases down the group. So as we mentioned here, the increases down the increasing in the atomic ionic radius. So here you see increasing atomic radius and the decreasing down the group. Next is ionization energy. It requires a minimum energy to remove an electron from the isolated gases. Ground state to form cations, and it is a higher ionization energy, that is equal to, which is more difficult to remove the electron also. So it is the minimum energy required to remove an electron from the isolated gases. Okay, at the atomic size decreases from left to right in a period, more energy is required. More energy is required to form an electron. So the ionization energy increases along the period, but down the group atomic size increases, and hence the valence electrons are loosely bound. So then the ionization energy decreases down the group in the periodic table. Okay, this is about the ionization energy. Next is about electron affinity. Electron affinity, it is the amount of energy released when an isolated gaseous atom gains an electron to form its anion, like ionization energy. So the electron affinity also increases from left to right and decreases from top to bottom in the group. Okay, so next is the last is about electron negativity. It is the measure of tending of atom to attract the shared pair of electrons towards itself in the covalent bond. So the chlorine atom has the higher electronegativity, hence it pulls the shared pair of electrons towards itself to form a stronger than the hydrogen. So this is about the electronegativity. So it is also based on the bond energy, ionization energy, and ionization potential and electron affinity. So this is about electronegativity. And this is about the periodic trends, where ionization energy decreases along the period, electron affinity decreases along the period, down the group, atomic radius decreases, and atomic radius increases down the group, and non-metallic atom increases, metallic atom decreases, and the electron affinity increases along the group, and the ionization energy increases along the group. This is about the periodic trends. So these are all about the classification of elements. Thank you. So we shall meet in the next session. Thank you for the patient listening.